Hello, in this video we're going to talk about translating graphs. This should help you with an assignment that you'll have later involving translating graphs. So first of all, what is our content and language objectives? Our content objective is I can translate displacement and velocity versus time graphs. This should be our language objective is I can write an explanation for how and why patterns occur in translated graphs. So first off, what is translating graphs? Translating graphs is the process of changing one motion graph to another from position or velocity versus time to velocity or acceleration versus time. And so one of the first most important concepts here is what is velocity and what is acceleration. And so velocity is a change in position over time, and acceleration is a change in velocity over time. And so how you indicate change on a graph involves slope. And so if you have a position versus time graph that's shown in the first example over here, what you have is a positive slope. And so if you have a positive slope, that means you have a constant change of position over time. And so that means you have a constant, positive slope. You have a constant positive velocity. And so how would you show a position versus time graph as velocity versus time? This line here is our zero line, this horizontal, this x-axis. Anything above that x-axis is going to be a positive value. Anything below it would be negative. And so we have taken this constant movement in the positive direction, and we've drawn it as a constant velocity. So over time, over this entire range of time, our velocity is constant and it's the same as shown in this position versus time graph. And we'll go through lots of examples will make sense of this. And so for this example now with velocity versus time, since this is a flat line, that means our slope is zero. And so we have no change in velocity over time. Our velocity is constant, which means our acceleration is zero. So moving down, constant slope. It says if the slope of a position versus time graph doesn't change, it means the velocity doesn't change. And therefore the graph is a flat line on a velocity versus time graph. This will make a little bit more sense in a moment, but if I zoom in really quick, the pattern that we're going to see with translating graphs is if you have a curved line and you're going from position to velocity or velocity to acceleration, it is going to become a sloped line. And so if we start off here, if we're drawing like tangent lines here, we start off with a slight slope and then it becomes a steeper slope. And so what we're going to see is a positive and increase change in the positive of velocity or acceleration. Anytime you have a sloped line, it is going to become flat at that particular slope. And so if I'm drawing an X and a Y axis here, if this has a positive slope and it's a position versus time graph, it's going to have a positive velocity. And any flat line is going to become flat at zero. And so there's no change in here because the line is flat, which means we would then have a flat line at zero. And so just the pattern as we go through these problems, it'll make sense as you rewatch this or as you see some examples, is curved lines become sloped. Sloped lines are going to become flat at that slope. And then flat lines are going to become flat at zero. And so like I said, as you watch some examples, as you come back to this, it should hopefully make some sense. Let's erase that real quick. So scrolling down a little bit, just one example here, and this is where it might start to make sense. It says changing slope. And so if I have this graph that's shown to the side, what I always like to do is break problems into chunks where something different happens in the graph. And the reason I broke it into these chunks right here is I see on the graph, this is a sloped line, and then it becomes curved, and then it becomes sloped again. And so there are three different sections of this graph, if that makes any sense. There's a sloped line that's going to become flat at the slope. There's a curved line that's going to become sloped. And then there's a sloped line that's going to become flat at this slope. And so this first section, let's just call it section A, it's sloped and it's negative because it's going down and to the right. So what that means is if this is a position versus time graph, during this first section, for the first 2 seconds here, what we have is a negative velocity. We have a negative slope in a position versus time graph, which means we then have a negative velocity. The third section, I'm going to skip right to the third one. You have a positive slope in this position versus time graph, which means we have for this third section a positive velocity. This is the 0 line, and so it falls above that. And just one little tip, any curved sections, I always save them till the end, and then I just play connect the dots. And so what do we have in this velocity versus time graph? We have a flat section, we have a slope section, and we have another flat section. Any flat section is going to become flat at 0. Any flat section is going to become flat at 0. And any sloped section is going to become flat at the slope. Since this is moving up and to the right, we have a positive slope here, and so we're going to have a positive acceleration. Continuing down to the next examples, again, now this problem has broken the graphs into different chunks. We have a slope section, a curved section, we have a flat section, another curved section, and then a slope section. And so the slope section, positive slope, has a positive velocity. Curved, I'm going to wait on, but this flat section becomes flat at 0. Again, I'm going to wait on this curved section. And then the slope section is going to become flat at this slope. And so when you graph out most of these sections, and then you play connect the dots with any of the curved sections, you end up with a graph that looks like it does. Again, to erase my little mess that I've created here, to explain how do you go from velocity versus time to acceleration versus time. This section is flat, this section is flat, this section is flat. And so all 3 of these become flat at 0. What you'll notice is that you have a slope section that's negative, and so you have a negative acceleration. You have a slope section that's positive, and so that's going to be positive acceleration. And again, just vertical lines to connect any sections with these sorts of problems. I know this is a difficult concept. Again, what I asked you to complete for some work here, complete these bottom 3 problems where you go from position to velocity to acceleration. If you struggle and don't feel like you can go backwards from velocity versus position, we didn't talk about that. Don't worry about it. And then position to velocity to acceleration. So try those problems and see what you can come up with. Keeping in mind the entire time that any curved line is going to become sloped. Slope becomes flat at that slope. Don't worry about absolute values here, just positive, negative, or 0. And then flat lines become flat at 0. That's all I've got. If you have any questions, please feel free to stop on for that homework help, the virtual science homework help, and I'd be happy to walk you through these. Thank you.